Let me restart the live stream. Let me restart the live stream. Okay, make some noise.
Hello. Testing, 1, 2, 3.
Okay. Okay, make some noise.
我已经 transfer
Hello. Testing, 1, 2, 3.
Okay, so I think does someone want to write up for the like the announcement?
Hello. Testing, 1, 2, 3.
Okay, so I think does someone want to write? Okay, then I think we can kind of begin if you want, if you're ready.
Begin now, is it? Are we letting participants into the Zoom? Hello.
Okay, YouTube stream seems good. Can just let people in already lah. Toggle the recording, then I think all's good already.
Can I get an okay from? Are we okay to begin?
Yeah, okay. Just let him in.
Okay, then I'll just admit everyone. Hey, hello everybody. Welcome back from lunch. So we'll be also streaming this live on YouTube for those who are unable to join into the Zoom itself. So if your friends are hard capped by the 300 participant limit, you can send them this link. So we'll begin this workshop now by the SDS workshops team. So today we have Wei Liang, Javier, and Keith, who will be presenting on some basic tips and tricks that y'all will need for this data analytics competition. So Wei Liang, you want to take it away?
Yeah, all right, sure. So hi everyone, welcome to our beginners workshop for the data analytics competition. So this is meant to be an introductory workshop, and it's not meant to provide all the answers to you, but just to help you get started and introduce you to some basic skills that you'll probably need throughout the workshop. Okay, so I'll just jump right in. Okay. Right. So today's topics. So first of all, we'll be covering some common data science tools. So Conda, which is a package manager, and Jupyter Notebook, which is a coding environment popular in data science. Following that, we'll be doing some data engineering, managing geospatial data with Folium, and some basic exploratory data analysis. Okay. Right. So I'll start first with the data science tools. So first of all, I'll talk about Anaconda. So Anaconda is a popular distribution of Python and other scientific computing libraries such as NumPy, Pandas, and sklearn. You've probably heard of these libraries before if you've done any data science work. Okay. So there's also a lightweight version of it called Miniconda. So you can choose to install that instead if you don't want to take up so much space on your computer and you don't mind the libraries needing to be downloaded along the way. Okay, so more importantly, Anaconda comes with this package manager and environment management system called Conda. Okay, so it's a pretty useful thing that allows you to install libraries and manage dependencies automatically. And more importantly, it allows you to have multiple environments on a single machine. So what do I mean by multiple environments? So one environment is like a single setup of libraries for a specific project. So for example, I could have one environment with PyTorch to do a deep learning project, and I could have a different environment with all the geospatial data libraries in order to do a data analytics project, for example. So you're probably wondering, like, why even bother keeping separate environments, right? Why not just install everything onto your machine, onto your main machine? So there are several reasons we do this. So first of all, right, this allows you to have several versions of the same library installed on your machine. So maybe you had one project that used an older version of PyTorch and it doesn't work with newer one for some reason. So this will allow you to keep like both versions of PyTorch on your machine in different environments and they don't mess with each other. Okay, and then a second reason is that this allows you to track specifically which libraries and your versions are used for a specific project. So this allows you to reproduce your results in the future because you know exactly what your machine environment was like at the moment when you did your project, right? Like you know exactly which version of TensorFlow and which version of NumPy you were using. Okay, and this also allows for easier collaboration because you can share your environment configuration with your teammates so they can have all the exact same libraries and the exact same versions, and you can ensure that all of you are getting the same results. Okay, finally, another useful thing is that if you're short on space, you can export your current environment to a configuration file, and then you can delete the libraries from your computer. So this is pretty useful because some libraries are quite huge actually, and they can take up multiple gigabytes of space. So like for example, the deep learning libraries come to mind. All right. Okay, so now I'll show you some basic commands for working with Conda. Okay, so let's say you've installed it already from the website, so it's pretty simple. You can simply type in Anaconda prompt on Windows or the terminal on Mac. Okay, so you see a command line interface like the one that I have here. Okay, so hopefully you've worked with command line before, but if you haven't, then I think all you really need are two very simple commands to navigate around. So the first one is to change the current working directory. So you can see that this is your current directory, right? I mean the C drive users, then my username. Okay, so if I want to change my current directory, I just have to type in CD followed by the relative path of where I want to go. So for example, if I want to go out by one folder, I type in ... Okay, this is like a shortcut for going out one folder. Then to go into another folder, you just type in the folder name. So you can chain these instructions to get to where you want to go. All right. And then secondly, right, you can print the contents of the current directory, like show you all the files and folders that are inside using the dir command on Windows or the ls command on Mac. Okay, so maybe I'll just quickly demonstrate this to you. So here I have my Anaconda prompt. So if I want to print out my current directory, I just type dir, hit enter, and then you can see all the folders and files I have. Okay, and if I want to change directories, like for example, I want to go into my documents folder, I just type in cd documents. Okay, and then now you see that my path has changed. If I want to go back out, I just type cd ... and I'm back out one folder. Okay, so that's some basic command line commands. Right. So now moving on to Conda itself. So Conda has a lot of commands for you to manage your environments, but I would say that Conda commands are pretty intuitive to use. Okay, so I'll just start explaining them one by one. So Conda comes with a default base environment. So you can see it here, where I have this thing called base right here, right? So this tells me that I'm currently in the base environment, but we shouldn't use this as our project environment. When we want to create a new project environment, we need to manually create the environment with the name we want. Okay, so to do that, we can use this conda create. Then the dash name specifies that I'm going to key in the argument for name. So dash name, then the name of the environment that I want to create. Okay. And if I need to list the current environments on my computer, I just type in conda and list. Okay, so I'll just show you what I mean. So if I want to show my current environments, I just key in the command, press enter. And yeah, I see my current environments being listed out. So I have one for a previous module I took, I have one for deep learning and so on. Okay, so let's say I want to create a new environment now just to demonstrate things. So I just do conda create dash name, and then maybe call it trial. Okay, I hit enter, and then I just press yes. Okay, so you can see that it's not actually going to install any packages because I didn't specify what packages I want in this environment, right? So if I type in conda list to show, sorry, wait, rewind. So first of all, right, to activate an environment, we have to manually tell conda to activate it. So to activate the environment we just made, type conda activate, then the name of it, so trial. And then now you see that base has changed to trial. So this means that we are inside the trial environment. Okay, so now I can tell conda to list out what packages I have in this environment. So I can do that with conda list. And you can see that I have absolutely nothing inside. Okay, so I guess now you're going to have to install some packages. So let's say I want to install, well, first of all, I need Python, right? So I type in conda install Python. And then let's say I want a specific version, so I can specify that as well. So let's say 3.9. And let's say I also want NumPy. Okay, so I can just hit the space and then type in NumPy as well. Press enter. And then you see that conda is starting to determine what dependencies I need and then list them all out. And then I can just type in yes to install everything in this environment. Okay, so in the meantime, while conda is doing the work in the background, I'll just explain the remaining commands. So right, so activate is done. So if I want to go back to the base environment, like for example, if I need to delete my current environment, then I can deactivate it by typing conda deactivate. If I need to update a package, I just do conda update package name. Okay, so it's quite intuitive. You can check out the slides on your own later. Okay, so I'll just move on. Right, so the other useful thing you can do with conda is you can share environments, right? So for example, you just like set up an environment and you want to share it with your teammates so that they can replicate the same environment on their own computers. Okay, so we can do that by exporting the environment to a configuration file. Okay, so the command for that will be conda environment export, specify the name of the environment you want to export, and then just direct it into a .yml file. So I can name this YML file whatever I want. Okay, it's up to me. Okay, so I'll see if I can do that right now. Yeah, so see, like now my environment has been, my libraries have been installed. So if I type in conda list, you can see that everything has been properly installed. So now I can try to export this environment to a configuration file. So I'll just do conda env export name trial, and then direct it to say trial.yml. Okay, and then it's done. So I'll just go into my file explorer and I should see the configuration file there. Right. So let me open my file explorer. So in the meantime, let me open this. Okay, so you can see that I now have this configuration file within my file explorer. So it contains all the dependencies that I need for this environment. And by sending this file to my teammate, your teammate can use this file to replicate the exact same environment on their own computer. Okay. So if you're experienced, you can even set up the configuration file beforehand and then create an environment based on the configuration file. All right. So next, let me check if there's any questions. Okay. No. All right. So right. So some other commands you can take note of, but you can always look them up if you need to, because there's no need to memorize anything. So you can delete an environment quite easily if you don't need it anymore. You can create the environment from the configuration file, as I was saying. So just make sure you're in the right directory, because this, by just putting this right, it means that this file will be in the current working directory that I'm in. Okay. Otherwise, I have to give like a relative link, like look in this folder, then you find the file, something like that. All right. If you need to tell Conda to clean up all the unused installation files or unused libraries, you can type in Conda clean dash all, and this will help you save space if you have a lot of unused libraries on your computer. And finally, you can even update an environment from a configuration file. Okay, but just remember to deactivate the environment first so there's no conflicts. Okay, so this is just the basic ideas behind creating, managing, and sharing data science environments. So for more commands, you can simply look up the Conda documentation, or there's also a Conda cheat sheet, which I have linked here in the slides. So we're going to be sharing the slides with you all after the workshop. Yeah. Okay. All right. So now I'll just move on to something else. So now I'll talk about Jupyter Notebook. So I guess you might have heard of it before. But for those that haven't, it's a popular web-based interactive development environment that's commonly used by data scientists. So the difference between this and your normal like Python IDE or whatever, or some Java IDE, is that code is structured in cells, and the output of individual cells is displayed directly below them. Okay, so this is quite a different paradigm from how code is normally structured in a single text file, right? And then code can be cells can also be run in any order you like. So this allows for a very interactive coding experience, and you can do a lot of experimentation more easily as compared to the normal way where you only have one text file that you have to rerun the entire thing. Okay. And then Jupyter Notebooks also let you intersperse markdown cells and code cells. So markdown cells are for displaying formatted text. And this can be useful when, say, you want to display images, you want to describe what the cells below are doing, to distinguish sections and all that. Okay. And finally, because of the fact that each cell's output is printed below it, it's easy for you to visualize results as you go. Okay, so that's an overview of Jupyter Notebook. So you can install it on Conda quite easily. You just do Conda install Jupyter, and then once it's installed in the currently active environment, you can just launch it by running Jupyter Notebook. Okay, so yeah, okay. So to create a new notebook, so once you launch Jupyter Notebook, you'll open something in your browser. So this is like the main page. So this part here shows you the current file directory you're in, so you can use it to navigate in and out. And then this part here lets you create new Python notebooks wherever you in the current folder. Okay, it's quite intuitive, so I'm not going to actually demonstrate this. Right. So so in the next part, I'm going to demonstrate some basic functions within the Jupyter Notebook. So if you want to follow along, you can head to the following website and click on this button here. Okay, so you should end up seeing some kind of working Jupyter Notebook, and you can play around with it. Okay, of course, if you have it already installed, then you can just launch it using the command that I mentioned earlier. Okay, so I'm going to do that on my own PC right now. Here, I deactivate the current environment. I activate the test environment that I made earlier. Okay, and then this one has Jupyter already installed. So I'll just type in Jupyter Notebook and it will launch in my browser. Okay, so I'll just bring over the browser window. Okay. Yeah, so you can see here the page I was telling you about. So I'm just going to open a notebook file. Okay. Right, so you all had enough time to click on this link and open the notebook already. Okay, I'll just give it like 20 seconds. Okay. All right. Okay, I'll move on then. Okay, so the main thing you should take note of when using Jupyter Notebook is that there's actually two different modes that you need to be aware of. So there's edit mode and there's command mode. Okay, so what's the difference? Well, edit mode is for when you're editing the contents of a single cell, and then you see the cell highlighted in green, okay? Whereas command mode, right, is for navigating around the entire notebook and modifying the notebook structure. So I could delete cells, copy cells, move cells, and all that. So you'll see that the current cell is highlighted in blue instead, okay? So in the different modes, right, your keyboard shortcuts will do different things, okay? So it's important to be aware of what mode you're in. Okay, so to transition between the two modes, you hit enter to go into edit mode. Or rather you hit enter and then you start editing the current cell, and you can press escape to go back into command mode. Okay, so quite simple. You can follow along in your own Jupyter notebook. Okay, and then here are some keyboard shortcuts for working in command mode. So you can save the notebook, you can delete the current cell, you can insert a new cell above, insert a new cell below, undo a deleted cell, and then convert the current cell to either a code cell or a markdown cell. Okay, so I'll just quickly demonstrate that on my own computer. So, okay, so if I want to, let's say I make a new cell below, now I'm in command mode, you can see that with the blue highlight. So I press B, and then a new cell immediately appears below. Okay, if I want to delete the cell, I just hover over it and press D twice. Okay, and it's gone, right? What else is there? So, okay, so maybe I'll talk about the code cell and markdown cell. So there are two different kinds of cells, main kind of cells that you use in a Jupyter notebook. So coding cells and markdown. So code cells are quite self-explanatory, right? They store code. So you can, for example, you could type in x equals 5, print x. You get 5, right? So that's a code cell. Whereas for markdown cells, it's a way of formatting text, right? So you key in your text in this specific markdown format, which I'll talk about a bit later. And then when you run it, it'll be nicely formatted for you, okay? So basically the keyboard shortcuts allow you to quickly convert a cell to either markdown or code, okay? By press M, it becomes a markdown cell. Press Y, it becomes a code cell. So all this is in command mode, okay? With, as you can see from the blue highlights. All right. So for edit mode, it's even easier, right? Just to run the current cell, you just press Shift Enter. And then to open a tooltip while coding, right? Like for example, you forgot what a function means, you press Shift Tab, okay? So let's see. So if press Shift Enter, you see that the cell runs. Then if let's say I'm typing something like I'm typing print and I forgot what this does, I press Shift Tab, you see the tooltip pop out, okay? If you want like a more detailed tooltip, right, you have to press Shift Tab. You have to press Tab 2 times while holding down Shift. Okay, so you can give it a try. You see that it opens a bigger window. I can read all the documentation right here. Okay, so I hope all of you managed to do this on your own. Okay, all right. Okay, so just a word of warning. Like because of the fact that each cell is in individual, the code is in individual cells, and these cells can be run out of order, right? It's easy to get confused and start making mistakes because basically, right, one important thing to know is that all the code cells are sharing a single persistent execution environment. So in other words, the variables and all the imports, they're all maintained unless you restart the entire kernel for the notebook, okay? So what do I mean by this? For example, right, if I press x equals 5 here, I type in y equals 5 in this cell. And then in this cell, I can do print x plus y, right? And it's fine because all these cells share a single environment, okay? So I could even do this out of order if I wanted to. So let me restart the kernel. Okay, so like for example, I could do y equals 5, x equals 5, and print x plus y, and it's fine also. Okay, so you can see from the numbers which cells will run before, which cells will run first. Okay, but my advice to you, right, is that try to restart the kernel sometimes and make sure all the cells can run in order, because otherwise it's going to be a bit weird when you say you want to share your notebook with your teammates, right? Ideally, all the cells can run in order and everything works fine, okay? Okay, so I'll move on. So I was talking about markdown cells just now, right? So it's basically just a way of typing formatted text. It's quite popularly used on GitHub also for all your forum comments and pull requests. You also can type type everything in Markdown format. Okay, so I don't think I'm going to go through the basic actions today. I think there's no point. You can just check out this link, www.markdown.tutorial, and then just you can see all the shortcuts yourself. Okay, so here I've listed a few of the more common ones. You can check this out later. Yeah. Okay, so just a bonus section on notebook extensions. So Jupyter Notebook also supports many community-created add-ons to the base notebook experience. So some of these are pretty cool. Like there's this thing called Scratchpad. So it's an extra cell you can like bring up and down whenever you want to do any rough working. So I just show you what I mean. So I can press Control B, and then now I have an extra cell if I need to do any like quick math or anything. Right. So it's just a convenience function. Yeah, and I can hide it again. Yeah. I can have collapsible headers. I can automatically generate a table of contents, and I can even have auto code formatting. So these are all like community created add-ons. So you can run, you can install notebook extensions by running the following two commands in Conda. Okay, you can check them out later. And then after that, right, on your main Jupyter page, right, you should see this new tab called MB extensions, and then you can activate the extensions that you want. Yep. So like, for example, if you go to home page, now I have this tab called MB extensions. Okay. Then when I click on one, I can see like what it does, and now I can customize it as well. Yep. Okay. So that's extensions. Okay, so now you're probably wondering, like, why not just use Google Colab, right? So some of you have probably used it before. So basically, it's like a web-based variant of Jupyter Notebooks that Google created. So they customized it quite a bit, but the concept is still the same. So you still have cells that individual cells that you can run, and then the output of each cell is displayed below it. Okay. So it runs off Google servers, and there are some small differences, like the keyboard shortcuts are a bit different, but functionally it's pretty similar. So you can access it at this link. So why use like Jupyter Notebooks instead of Google Colab? Or why not use Google Colab instead of Jupyter Notebooks, right? So there are pros and cons of each. So I'll just go through a few. So first of all, right, I mean, you would use Google Colab when, let's say, you don't have a powerful computer, or you don't want to run your code for a long time on your own computer. So you can use Google's computing resources instead. And they have free GPU instances as well. But of course, with every pro, there's a con, right? So there are usage limits to Google Colab, and you need to be always active and connected. Otherwise, it's going to time out. And this timing out thing can be quite irritating when you're running something that takes a long time, right? So like, for example, you're doing some kind of machine learning experiment that takes like an hour. Then it times out 30 minutes in. So when it times out, like everything that's done so far is basically lost, right? Because the machine gets disconnected. So that's pretty annoying. So sometimes you might rather do it on your own computer, especially if you have the computing resources. And then another pro of using Google Colab is that you have a lot of the common data science libraries already installed, but that also means you have less control over the data science environment, because Colab has this default image that it always defaults to. Okay. And then finally, Google Colab allows you to sync with Google Drive and share easily with others, but this also means that you cannot access your local files directly as you would on your own machine. So if you say you had a very large data set, it can be quite irritating to have to upload it to Google Drive beforehand. Okay. So again, there's different pros and cons, and it's really up to you. Oh, but something to take note of for both, right, is that you can't edit either a Jupyter Notebook or a Google Colab file concurrently with multiple users. Okay, so never do that, because if you do, right, someone's gonna lose their work basically, because the save is just gonna overwrite. You cannot. It's not like Google Docs where you can edit the same document concurrently. You can't do that with Google Colab files, so don't do it. Yeah. Okay, so yeah, so it just depends on your context and on your needs. Okay. But in any case, if you know how to use a Jupyter Notebook, right, you should be able to figure out Google Colab pretty easily, because the concept is more or less the same. Okay, so these are the references. You can check them out if you want to learn a bit more. And otherwise, I'll pass the time on to Keith, who will be talking more about geospatial data analysis. Okay, stop sharing.
Share screen. Okay, now you can see my screen. The link to the participants' copy of the Google Colab has been sent to the chat. So what I need you guys to do is when you open that link, go to the file and save a copy in your drive so that and edit and you can code along with us in your own personal copy in your drive. So without further ado, I'm going to go straight to the objectives. So I'm going to go through data preparation and engineering, introduction to Geospatial library called Folium, and I'll pass on the time to JV afterwards to go through a preliminary analysis of the dataset. So first, this will be the dependencies that we need, the libraries. So firstly, pandas will be used to read in the data and do data manipulation. High error and fast parquet are engines used to read the parquet files. When you see later, the files are not given in CSV or Excel format, but rather in this weird format called parquet, which you might not have heard of before. And of course, Folium, the library itself, and Branca, which is a library that we are going to use with Folium. So first, we need to import drive and mount the drive. So I've already mounted my drive, so I'm not going to run this again. So after you mount your drive, you'll be able to unzip the folder of the drag dataset. And before you run this, I'll need you guys to go to the drag dataset shared with you earlier, right-click on it and add a shortcut to your drive. This is because when you add a shortcut to your drive, this code will be able to run because you're unzipping the zip file directly from your drive over here and from this folder called drag.cc dataset. So once you have added a shortcut to your drive, you can run this and it'll unzip the files into 9 different parquet files. So I've already unzipped it, and once you mounted your drive and unzip, you'll be able to see a new folder here with all the different files. Okay, so next up, I'm gonna go straight to data preparation and engineering, import pandas and datetime. The datetime library is used to manipulate the datetime elements inside a dataset. So if you've used pandas before, you'll be quite familiar with how to read in data. Most probably, the most common method is using CSV files and Excel files. But in this case, the files given to us are parquet. So there's this function called read parquet, and we need to specify the engine. So in this case, we can either use a pi arrow or the fast parquet engine, which I specified above here just now. So once you run this, you'll be able to see the dataset. So a note for you guys is that this ping timestamp column is actually in Unix time. And what it means is that it's the number of seconds from 1st January 1970. That's why the numbers here are very huge. So like what we always do when we see a new data set, we'll call the .info method to get a summary of the data set. So in this case, we see that we get all the columns and their data types. And it gives us a memory usage that we are using as well. In this case, it's 200 MB. So we have one of these data set, which is 200 MB in size, but we have the zip folder actually contains a lot more. So we want to try to optimize the usage of storage as much as possible. So what we can do is that we can change the data type into some other data type which uses less space. So I've attached a picture here which shows the different data types and the space that we use. So for example, int 8 is basically 8 bits, which is 1 byte in storage, and int 16 is 16 bits. And this table description shows the range of values that this data type can hold. So we have defined a few functions here. Let me run it. The functions defined here are meant to change the data types to optimize our space. So the first one will be to category. What we are doing is we are going to change all the object data type, the columns with object data type, into category instead, which uses less space. To float 32, we'll change all the float objects. Right now it's in float 64 into float 32, which uses less space. And we'll do the same for the integer columns. Lastly, we define a format datetime function, which will be able to format the Unix timestamp into a datetime object where we can do our analysis with later. And from there, we can extract the time, the weekday, the month, and the year from the datetime object. So once we've done that, we're going to make a copy of the dataset. And on that copy of the dataset, we're going to do the relevant engineering. So it might take a while to run. So what I'm going to tell you is that right now, format datetime, there's only one column which we need to change, which is a ping timestamp. To category, we have three object columns up here: trajectory ID, driving mode, and OS name. So that will be our parameters into category function. And it will be the same for the conversion of float and integers. So it's still running, so we're going to wait for it to run. After it has run finished, we're going to run the info object and see the memory usage of the list. Okay, I'm going to let it run. Okay, so ran finished. So let's check the info again. You can see that now the memory usage has decreased a bit. Like previously, it was 208.4. Now it's 117. So this is how we can reduce our memory usage and optimize our performance. So let me call describe method now to get unique statistics of all the columns over here. So I'm going to go straight into Folium, which is a library that we are introducing. So what Folium is that it's a geospatial viz library which builds on the data wrangling strengths of the Python ecosystem and the mapping strengths of the leaflet.js library. So the leaflet.js library is actually a geospatial library that runs on JavaScript. It's open source, so you can check out the documentations here. I've added a link if you are interested to find out more. So what Folium does is that it's actually similar to, it's like an extension of this library. The geospatial plots are mostly from this library itself. So we are going to import the relevant libraries we are using, Folium, and from Branca.element, we are importing figure. This figure object is something similar to matplotlib. We'll be creating a figure before we overlay the Folium map on it. So let's try looking at Singapore map. So this is a latitude and longitude of Singapore. And from here, we're going to create a map of Singapore. So first, we define the figure, similar to matplotlib. We'll predefine a figure with a certain width and height. After that, we'll call folium.map, which creates a geospatial visualization. So specifying the width, height, location will be the latitude and longitude of Singapore in the list. And it takes in a list as a parameter. Zoom start, min zoom, and max zoom is a zoom levels that we want to give to the map. So zoom start is like the initial position of the map once it's loaded. Minimum zoom is how far away we can zoom out, and max zoom is how close we can zoom in. So if I'm going to run this again, it's going to show this. And right now, zoom start is at 11. So this is a zoom depth at 11, which is also the minimum. That's why we are unable to zoom out anymore. And we can zoom all the way to zoom 16, which is right now over here. It's quite interactive in the sense that you can drag and like look around the map. So there's a parameter to define the tiles for the map. By default, the tiles are set to OpenStreetMap, which is similar to what you see like maybe when you open Google Maps. So this is OpenStreetMap tile, but there are other tiles like statement terrain, statement toner, etc. So we're gonna explore one more, which is the statement terrain. So this is essentially the exact same code, just like we are specifying the tiles to statement terrain instead of OpenStreetMap. So what you're gonna see here is the same map, but looks different because we are using different layout tiles. So I'm going to introduce a few markers next. So markers are basically like the pins that you see, like the red pin you see when you search for a location on Google Maps. So since this is a geospatial plot, you can add like pins to certain locations. Sorry, can someone mute? Thank you. So I'm going to teach you like markers. So we can plot markers on top of the map to show specific coordinates as well. So right now we are taking this example, which is the first row of the data frame. And similar to earlier, we're going to predefine a figure and call the same map. And after that, we are going to call the folium.marker. And what this does is that it creates a marker with the specific location that is taken from the raw latitude and raw longitude column of the first row of the data frame. So the pop-up is basically the text that will show up when you hover on top of the marker. No, I'm sorry, the pop-up is what happens when you click on a marker. The tooltip is what shows when you hover on the marker. And after that, I'm gonna add to M2, and M2 is a Folium map itself. So when I run this, it's gonna show the map, and you can see this pin over here, like when you search for location on Google Maps. So you see an example I hover up here. So that's the parameter passing to tooltip. And when I click on it, the pop-up shows default pop-up marker 1, which is what's defined over here. Okay, so far so good. So what I'm doing over here is making a plot and adding 2 different markers with different pop-ups to the plot. So this is actually not very relevant because the location I specified here is somewhere in USA. It's not in Singapore. But since this is like introduction to the library, I just want to show you like the kinds of plot that the library can make. So this is like a mountain range. So sadly, Singapore, we are unable to get a map like this because we don't have like a lot of geographical features, which was why I use like USA as an example. And adding the markers on top, it shows like specific locations. So if you zoom in and you click on it, it shows like this is a timberline lodge and this is the non-hood meadows. And when you zoom out, you can actually see like the different cities over here. Yeah, so moving on, markers are something you can style with to make it look nicer if you want. So you can style it by adding color or adding icon to it. So in this code, it's essentially the same as earlier. The only difference is that in a marker, I added a parameter called icon, and it takes in an icon object, and you can specify the color and what icon you want. In this case, this icon is a cloud icon. In the second marker, I specify a color equal to green, and in the third marker, I specify both the color and the icon. So if you see over here, you can see the 3 different markers that showed up. Okay, so this is how you can customize your own. This is how you can customize your own map for your data analytics competition. So right now, I'll go through a let-long pop-up, which is something you can add to your geospatial plot as well. So what I'm doing here is creating the map again of Singapore, and by creating this, I add a child to the map M5. M5 is Folium.map, which is the map of Singapore that I define, and I add a child to which is Folium.let-long pop-up. So what it does is that whenever I click on the map, it'll show me the latitude and longitude of the specific location. Okay, so let's go and see where NUS is. So if I'm not wrong, it's somewhere here. So NUS have latitude of somewhere around NUS in the center, probably it's like 1.2958 and 103.7773. So let's add these coordinates to the next code. Let's see what will show up. So, okay, so what I'm doing here is I create another figure of Singapore, the same code as earlier, but right now I'm adding a circle object to it, and I specify a radius and location of the circle. So this location of the circle I put as the coordinates of the center of NUS, and there's a pop-up. The pop-up parameter I add as NUS, and I add a specific color and the fill color as well. And once I created this circle object, I add to M5, which is a Folium map. So when I run this, you'll see the same map. The only difference is that now you'll see a circle here of a radius of 750. So it's basically like encompass NUS itself. So this is how you can like add other stuff into your geospatial plots if you need for your data analytics competition. So this is a very, very brief overview of the Folium library that you can use to get started on your project. So next up will be basic exploratory data analysis, which Javier will go through. Javier, on to you.
Yes, okay. Thank you, Chief. Okay. Yes, I'm sure many of you are quite excited to go and explore the data already. But yeah, don't worry. So since this is the last part, I'll try to be quick. Okay, so what is exploratory data analysis? So we usually call it EDA in short. And it is just a process whereby we try to play around the data, or we explore the data to find out like certain interesting trends, patterns, or maybe even outliers. And then these are usually done using visualizations. And okay, so every time when we look through the data, right, we might have some questions we want to ask, or some simple hypotheses that we might have with the data. And then we can also use this time to go and test on against or for our hypothesis. So now if you ask me, so what do you specifically need to do in EDA? And then my answer would be, I don't know. Because there is no specific thing that you should or you need to do in EDA. That's why it's called exploratory, because you're meant to explore around the data and come up with creative questions or insights that you might have. But however, there's a few guidelines that I want to share with you to maybe just get you started. So the first way we can think of possible questions or hypotheses to ask or stuff to analyze is by looking at the problem statement. So here we have the problem statement, right? And okay, so it says that there has been feedback about delays. So if you read the entire problem statement, you know that this is the main problem that we have. And then you see that this led to decrease in customer satisfaction, trust, increasing customer turnover, blah, blah. So all this is not so important right now because these are just the byproducts or the effects of the delays. And there's also a clue here which says that this could be due to inaccurate ETA prediction or bad route planning or other factors. So we just have to look at delays in this problem statement and then, we try to work around that. So I think it'd be handy if you have like a notebook or something to write on, and then you can try to brainstorm ideas. So what can we do? Of course, I'm sure you all know about the 5 Ws and 1 H, right? So we can start asking ourselves questions like, why would there be delays, or why are there delays? Or maybe it'll be more appropriate to say, what causes the delay? And then maybe you can think, okay, maybe there are traffic jams, or maybe there are too much demand for the drivers and too little drivers. So it's a supply and demand problem. Or you say that maybe it's just bad ETA prediction. Because basically, if I tell you that your driver is taking 30 minutes to reach and he arrives in 20 minutes, that is not a delay, right? And if I say he will take 10 minutes to reach and he takes 20 minutes, so that's the delay. So it could be due to that. So we write down all our questions. And then after that, we can ask like when. So when would there be delays? Then there's something that we can go and analyze on. Where? So where would there be a higher probability of having like traffic jam or delay? And lastly, how, which is what they want. What insights can we get on how to mitigate this or reduce the number of delays? So we write all that down, and then we can see, we can build on that to further come up with new questions that we want to ask. So another way is we can look at our data frame, our data set, and see what available data we have and what insights can we draw from the data. Okay, let's just import the matplotlib and seaborn for visualization. Okay, so now we look at each column we have. So trajectory ID, if you're still confused, trajectory is basically like a trip. So each trip, it has a unique identification number, which is the ID. So you might start asking, so do you think that driving mode would affect the number of delays? So in this data set, we only have like cars and motorcycle for this graph data set. Okay, then maybe, who knows? Because I don't know for sure, but you can go and analyze it and come up with possible hypotheses. Then you can say that maybe motorcycles would have fewer delays because they can zoom through the traffic jam. Yeah, could be possible. And then you may ask, okay, so do you think the OS that they use, Android or iOS, might be the cause or might be correlated with the delays? I mean, you can just think of, okay, maybe they have certain, maybe there's a bug in the system for Android or iOS, and then that gives them the bad route or bad ETA prediction. Okay, then ping timestamp, like Steve said, this is just the number of seconds from 1st January 1970. Let and longitude don't affect delays. Speed, probably not, right? Because delays affect your speed, not the other way around. So bearing and accuracy, honestly, I don't think I'm not creative enough to think of a possible reason of how varying accuracy might affect delays. So I'm going to skip that for now. And yeah, and just the time, day of week, month, year, maybe they are correlated somehow. So that's whatever questions you have, you can just write it down, and then you can go and do some visualizations to think about it later on. So over here in the collect notebook, I've written down some questions. And yeah, do note that it is not exhaustive, because obviously there are hundreds and thousands of different questions you can ask. So let's just start. Like, remember the first thing I said, remember, why delays? Maybe it could be too much demand, too few drivers. So how do we search that? So let's say we just want to count the number of different trips that we have, right? Which is under trajectory IDs. So we can get trajectory ID column, and then we can use this function called n unique, which stands for number of unique. And then it shows you there's 28,000. We know that this, okay, yeah, do remember that this data set is just one small part of the Singapore data set. So in this one small part, there are 28,000 different trips. So is that a lot or is that very little? It's up to you to decide and analyze on. Okay. And if you want to see another way, you can try to find, you can use what is called the value counts. So this one, they will take every single unique trajectory ID, and then they'll count the number of occurrences it appears in the data set. So let's say, okay, this ID, this trip, has 678 rows in a data set. So you might think that it is a longer trip. And then this one only has 48. So this is probably a very short, very near trip. Okay. Then the other question that we asked just now, do you think that there's a huge difference between driving mode, and maybe if it will affect the number of delays? So we can just use Seaborn, which is one of the visualization library, and just plot a very simple count plot. Okay, wait, before that, we'd like to group all our trajectories together, because now each trip has different rows in the data, right? But we don't want repetition in them. So we want to buy the trajectories, the trajectory ID, and then we want to just get the first row of each data. So what this does is it just groups by all the trajectory, all the similar trajectories, and then you get the first row. So let's say for trajectory ID 10 is car, and then trajectory ID 100 is car, and then car all the way. Okay, then let's store this in just call it driving modes, and we can plot it out using Seaborn. Okay, so it seems like for this data set, everyone is using a car. So, okay, not much thing you can get here. But once you combine the data sets, right, maybe you're going to see like motorcycles, and then you can compare the distributions. So from there, you can come up with further questions, like if there are a lot of cars, and then the delays are, there's quite a lot of delays. So it could be correlated that it's because people are using car, not motorcycle. Yeah, and then you can come up with further questions by yourself. So then we're going to do the exact same thing, but now we're going to check on OS. We just copy and paste, and OS is on the third column, which has index 2. And we call it OS names. And we plot. Okay, wow. So from here, we can see that there are quite equal numbers of iOS and Android users. So maybe there's not so much correlation between like delays and OS users. Okay. Now, yeah, this is a very more direct question, right? So we know there are delays, and just now we asked the 5 Ws and 1 H, right? So we want to know when would there usually be delays? So every time we look at the data set, we can come up with hypotheses first by ourselves, and then we check if we are true. So my initial hypothesis is that there will be a lot of delays during the peak hours. And I define it as maybe 7 to 10 a.m. when people are going to work, and 5 to 7 when they're coming home from work. So how do we do this? So of course, we can just do, obviously, we don't want to plot every single minute out onto this. We don't want to plot every single minute, right? So what we can do is something called discretization. That's right here, discretization, which, or you can call binning. So we just say we split the time into hours, or you can do it in 2 hours or 4 hours. I think hours work well here. So let's just split them into hours based on their hour. So we take the time column, and then we apply a function to it and retrieve their hours. What we have now is all the hour of each trajectory. And then now we can do just another count plot. Wow, okay, we can see. And so take note when you're doing all this, right? Please keep in mind all your data visualization principles and stuff. And for this, I don't think the color, the gradient does works well. So I'm just gonna make it gray or something, or whatever color you choose. Okay, and then now we can see if our hypothesis was right. So surprisingly, I was half right in that from 9 to 10, there were the most numbers of trips. And then surprisingly or shockingly, from 5 to 7, they were the least. So there could be some problem here. I'm not sure why, but it could also be because this is just one part of the data set. So as you can see, this whole EDA thing is very iterative. So you have to just keep building on and on. Okay. And okay, now maybe you think that this is not so good because you are taking every single ping of every trajectory, and you just want to find out, okay, what is the starting time of every trip? So another way we can do this is find the starting time of every trip, right? We just do the group by again. We group by trajectory ID. Then we retrieve the time column, and then we just find the minimum. So this returns the first timestamp of every trajectory, as we can see here. So now let's store this in what is called initial ping, and then maybe then now, like before, we want to discretize it. So we just want to get the hour portion, because you see here we have hour, minute, seconds, and we don't want to be plotting like so exact. So we just call this initial pings hour, and we apply the same function to it. Okay, and then we can plot it out. Oh, sorry. Yes. Okay, and then again, you see that the color is not ideal, right? So you can change it on your own. But we see that the graph is largely quite similar, with 9 and 10 having the most number of trips starting at that time, and then 5 to 7 has the least. Okay, so of course there are a lot more other things that y'all can do, and these are just some stuff that I want to show you. Okay, so now remember at the start we had our 5 Ws, 1 H, right? So now we already solve the question of when is it busy and when there might be delays. So now let's try to find out where. So for this, we need to do our geographical geospatial plots, like what Keith went through just now. So let's just define peak period. So from our previous analysis, we realized that, okay, 9 to 10 is the most. So we can define peak period as being trips that start at 9 or 10. So how do we do this? We just, we have our hours variable just now, right? So hours equals to 9 or hours equal to 10. and then we store this in peak period. Okay. Now we want to get all their latitude and longitude because we want to plot them. So from peak period, we want to get their raw latitude, their raw longitude, and then we want to convert them to a NumPy 2D array because a function requires this. Okay. So now if you see here, our pins, these are basically the raw latitude and longitude of all the trips that starts during the peak hour, which is 9 and 10 based on our definition. So now this code here, what it does is the same as before. We create a figure, we create a Folium map, and then now we're using what is called the heat map. And we plot this, we put in the pins to the heat map, and we just plot and see. Whoa, nice. Okay. So basically, you can see that almost the entire Singapore is quite a lot of traffic going on, but that's because we are quite zoomed out. So for here, you can play around with the radius and the blur of the heat map to suit your analysis. So I guess from here, we can try to look more in depth, and you can scroll around and see. Let's say you're looking at Sembawang, right? Ulu Sembawang. Obviously, we would have guessed that it's not very packed over here. And then how about NUS? So you see NUS, and then you see this very red line here. I think this is the AYE expressway, right? So yeah, so you guys know, right? If you are coming to school, try to avoid the 9 to 10 a.m. if you're taking AYE. Okay, and then from here, what you can do is maybe analyze or you could give suggestions on what kind of route they should take. Maybe they can take a less crowded route. Maybe they can come through here instead. Yeah, so these are the kinds of things you can see from a heat map. Yeah, and so now we have solved when would there be jams and where would there be jams, and how. The how is up to you. Like maybe you can increase the estimated time of arrival, or you can find another route or something like that. Okay. And lastly, what I want to show you is this whole chunk of code here, is that if you want to go more in depth into each specific trajectory, right, you can plot what is called polylines. Okay, let's just walk you through the code. Yeah, this is the last part. Okay, so now I was trying to check the trips which have the slowest mean speed. So what I did was that with the peak period, with the peak period variable that we have, we group by trajectory, we get the speed, and then we apply this function to get the mean of everything. After that, because there are a lot of rows with nulls or any ends in their mean speed, so I retrieve the non-null rows. And then after that, we sort them by the mean speed. So the slowest will be on top and the fastest will be below. So we want to retrieve the 3 slowest trajectories, right? We can just do mean speed and use this function called n smallest. Or actually, we don't need to sort because we already have this function. So this one means I want the 3 smallest one based on mean speed. And we get the index, which is the trajectory ID. So I define a function here which will get with the provided data frame, they will get the latitude and longitude of the specified trajectory ID. Wait, let's run it. Okay, and then using the function, I get the roots of the 3 slowest trips. And I define another function here, which gets the start and end position of each trip. And then the same thing as before, we define a figure, we define a map, add a map to the figure. And now we're creating something called a feature group. So I call it the slowest, second slowest, and third slowest. And then this polyline is usually used when you are dealing with like geospatial data. So route 1, I get their values, which is all their latitude and longitude. And then, yeah, you just put it in here. Then you do that for route 2 and route 3. Then you add them to the map. Then you get the start and end points of each trip. And then we use the marker tool that Keith went through with you all just now, and add them for trajectory 1, trajectory 2, and trajectory 3. And then finally, we add what is called a control layer. So let's see what do we get. Yeah, so we can see from here, we have our map of Singapore, and then we have our 3 trips here. And now we have this additional control layer control here. So you can toggle whatever you want to see. And let's say you want to analyze, okay, why this guy, the slowest one. So you just click the slowest, then you can go in. You can keep overlaying stuff, like maybe you want to overlay a heat map or stuff like that. So from this, I guess you can come up with like different hypotheses or questions, or analyze further on why this would be the slowest, and why the second slowest is from like Ang Mo Kio to Harbourfront and stuff like that. Yeah, so I guess, okay, Folium is quite a useful tool in a sense, and of course there are many other tools that you guys can use, and yeah, it's all just up to your imagination and your creativity to find out interesting questions you want to ask, or stuff that you want to find out or analyze. And yes, so as we said at the start, this is just a very basic introductory workshop. So we didn't want to go too far in that, because we want to give you room to explore on your own, which is the point of this competition. And do note that there will be another workshop tomorrow held by Tribe Academy, where the speaker will go more in depth and give you useful tips and tricks for dealing with larger data sets and geospatial data. And yes, we don't want to keep you back any longer. So if you have any questions, do direct them to the Discord server in the appropriate channels. Yes. Can you get a final copy of the code file? Yeah, we can send them out after we're done, together with the slides and everything. So yes, thank you all for coming on a Saturday. So yeah, enjoy the competition and have fun analyzing all the data. And yeah, good luck. Okay, bye-bye. Welcome, bye-bye.